Hello students, today we'll see the concept of polygon where we'll see the test to check whether point is inside the polygon or outside the polygon. So we can consider two types of polygon, convex and concave. So how to identify whether polygon is convex or concave? So for that we can consider any two points which are inside the polygon. Then we'll consider the line segment joining that two points, and then we'll see whether line is completely inside the polygon or outside the polygon. If line is completely inside the polygon for all the cases, then polygon is convex polygon. But if line is partially inside and partially outside, then we can consider that polygon is concave polygon. So here we have shown two example of this. So here we can see if we consider any two points inside the polygon and if we connect this two point with line segment, then always we'll find that line segment inside the polygon. But in this case, if we consider these points and if we connect these two points with line segment, so here some part of line segment is lying outside the polygon. So such type of polygon is called concave polygon. So here we'll see one test whether test to check whether point is inside the polygon or outside the polygon. So there are two tests. First is odd even method and second is winding number method. So let's see odd even method. This method is used to check whether point P is inside or outside. So here in this diagram you can see 4 points, point A, B, C and D. So clear cut here we can see points whether they are inside or outside. So through test again we'll justify whether point is inside or outside. So here very first step is we have to draw a line from outside to that point which is to be tested. Then we have to consider intersection points of all this scan line with the polygon edges. So here we have drawn the lines from outside to that point, and now we can consider the intersection point. If we consider point A, then here there is a scan line which is drawn from outside to that point. Then this line is intersecting this polygon edge. So here we can consider this intersection point. So similarly we'll find all the intersection point for all these points which are to be tested. Then next step is we need to count number of intersection. If number of intersection is odd, then point is inside the polygon. If the intersection point is even, then point is outside the polygon. So it is a simple test. From the number of intersection we can decide whether point is inside or outside. So here we can consider two examples for point A and point D. For point A, there is single intersection. So there is only one intersection where 1 is the odd number. So if the number of intersection is odd, means point A is inside the polygon. Let's consider another example for point D. For point D, here this scan line intersecting two polygon edges, this one and this one. So there are two intersection point, 1 and 2. So there are two intersection points, so 2 is even number. So if there is even number of intersection points, then point is outside the polygon. So these are two simple cases for testing whether point is inside or outside. Along with this, there are two special cases when line is passing through the vertex of the polygon. So here you can see this line is passing through the vertex. If you consider this point B and C, for point C, this line is passing through this vertex, and for point B, line is passing through this vertex. If this is the case, how to test these points? If this scan line is passing through the vertex, then we have to consider the polygon edges which are meeting at that vertex. So here you can see that for this point B, these two polygon edges are meeting at this intersection point. So if this is the case, we have to check the direction of this polygon edges. If these two polygon edges are lying opposite to scan line, then we have to consider this intersection only once. So there will be only one count at this point. So by considering this as a single point, we have to again use the same technique. We have to count the number of intersection, and then accordingly we have to find whether point is inside or outside. Then in special case, there is another special case. If the polygon edges which are meeting at that point lying at the same side. For example, in this, for point C, we can see this scan line, it is intersecting this one polygon edge, then it is passing through the vertex where these two polygon edges are meeting. So here the direction of this polygon edge is they are lying at the same side. So this intersection we have to consider twice. So here we have to count this intersection 2 times. Plus for this point C, there is one more intersection here. So total there are 3 intersections. So 3 is again odd number. So accordingly, this point is lying inside. So in this we have to consider normal case as well as we have to consider special case. And by considering this test, we have to find whether point is inside or outside. So here again I have explained the same thing. There is the same example. There are 4 points, point A, point B, point C and point D. First we have to apply the simple cases. We have to just check intersection points. If number of intersection is odd, point is inside. If number of intersection is even, point is outside. But if scan line is passing through the vertex, then we have to consider special cases. And accordingly, we need to find the intersection points and we have to take decision. So this is what about the odd even method. Then there is another method also, that is winding number method. So again this method we can use for convex as well as concave polygon. Here you can see one concave polygon. So both tests we can use for concave as well as convex polygon. So what is the concept of this method? So here we can consider that there is a rubber band which is stretchable. So here we can consider a pin. Pin can be put at the point which is to be tested, and then rubber band can be fixed up one end at the point and another end can be moved across the polygon. So after completing one round, we can check whether there is a complete round around the pin or not. If there is a complete round, if there is a complete winding around the pin, then we can say pin is or point is inside the polygon. If there is no net winding across the around the pin, then we can say that point is outside the polygon. So this is what the concept of this method. So for implementation, how we can implement this? For implementation, we can consider, we can add some weightage for every line. So how we can add this weightage? So one can be added to the edge when we are moving from right to left, and we'll add -1 when we are moving left to right. Or in simple case, what we can do, we can give the direction to this polygon. Now here you can see there is a clockwise direction to this polygon, and every edge, when we are moving from left to right, we have assigned, or it is upward direction, we have assigned the positive 1. When there is direction from top to bottom, then we have assigned -1. So similarly, we have given here weightage for every edge. So here you can see when there is upward direction or right direction, then weightage is 1, but when there is a downward or left direction, then weightage is -1. So after giving this weightage, now the next step is, we'll consider a scan line from outside to the point which is to be tested, just like a previous method, and then we'll find out the number of intersection for the polygon. So wherever this scan line is intersecting to polygon edge, that weight will be considered. So here we'll find the net weight. So how we'll find the net weight? For example, this scan line is crossing 3 lines. So we'll combine the weightage of 3 lines. So if the weight is non-zero, then point will be lying inside the polygon. If weight is 0, then point will be outside the polygon. So here you can test for this point. This line is passing from this polygon edge where weight is 1. Here it is -1 and here it is 1. So here net winding is non-zero, which is here it is 1, which is non-zero. So point is inside the polygon. But when we get this weight 0, means point is outside the polygon. Here also we can consider the special cases when this scan line is passing through the vertex. So these special cases are very similar to previous method. When this scan line is passing through the vertex, we have to see the direction of polygon edges which are meeting at that vertex. If these polygon edges are at opposite side, then we have to consider this intersection only once. If polygon edges meeting at that point lying at the same side of the scan line, then we have to consider 2 times. This intersection we need to consider 2 times. So in this case, we need to consider weightage of both the line. And then again we have to find the net weight. If it is non-zero, means point is inside. If it is 0, point is outside. So these are 2 methods for checking whether point is inside the polygon or outside the polygon. So in next video, we'll see what are the different techniques for polygon filling. Thank you.